Alright, hi, so in this video we're going to show you how to do sig number 9, which is basically derivative rules. This is the power rule with a little bit of chain rule. The main rule we're applying here is if we take the derivative of some function to the n power, you basically just bring down that n, the function stays the same, you subtract 1 from the exponent, and in some cases you may have to multiply by the derivative of the inside piece, right? But for most things, if it's just an x right there, you're simply bringing down that n and subtracting 1 from the exponent. We also need to know is if I take the derivative of a constant, you will get 0, and if I take the derivative of x, I basically get 1, right? So here we're trying to take the derivative of this guy. So we're finding f prime of x. We're going to bring this 4 down to the front, which makes it 8x, and we subtract 1 from the 4, which is 3, and then we take the derivative of this guy separately, which is going to be 6x, subtract 1 from that 2, and we get 1 like that, and that's simply what that guy is there. Okay. For number 2, we need to rearrange this a little bit before we start taking the derivative, meaning the power rule does not apply unless the term is in the numerator, right? So I can't do this for this middle term because this does not apply for the denominator or division. So what we do is we bring it up to the top and make that exponent negative, right? We're using this property where if I have 1 over a to the n, that's the same as a to the negative n over 1, right? And now that everything's in the numerator here, we can go ahead and take our derivative, right? That first step I did not do any calculus. We'll bring this negative 2 down for the first term, negative 2x, we're going to subtract 1. Negative 2 minus 1 is negative 3, plus this next term we bring down the negative 3x, we subtract 1, we get negative 4, plus the last term we bring the negative 4, negative 4 times 4 is negative 16x, you subtract 1 and you're going to get negative 5. We do not want to leave our answer like this. We need to simplify it as much as possible, which means no negative exponents. So we bring that x cubed down. Notice how the 2 does not come down, right? The 2 does not have a negative exponent. It is a negative number, but it does not have a negative exponent. This one's going to be over x to the 4th. This is going to be 16x to the 5th. All these plus minuses, an easier way to say plus negative this is simply subtract, right? And again, the coefficients are not coming down. The only time a coefficient would come down if we saw it like this, right? If the whole thing were in parentheses, then I would bring it down like that. But that's the only case, and we're not, that was just, a side example. We're not doing that. All right. So that was our answer here for this one. On to the next one. Here you see you have radicals. So the first thing we need to do is we don't know how to take the derivative of radicals, so we're going to go ahead and write it in exponential notation, which in this case the index of the radical is the denominator. So let's just do a quick example. If I have n x to the m power, this will be x to the m over n, right? The n is the denominator. So in our problem here, it's going to be negative 4x to the 2 over 5 plus 2x to the, there would be a little 1 here if we had to write it, so 1/4. Now we need to apply product rule on this, right? So this is going to be f prime of x equals negative 4. We bring down the 2/5. Because it's a little more complicated, I don't really know what 4 times 2/5 is yet, so I'm going to want to write it there. X to the 2/5 minus 1. Do I know what that is? Well, let's do it over here. Let's do some side work again. Notice I'm writing on the left side of the screen. 2/5 minus 1. 1 is 1 over 1. We need to find a common denominator, which is going to be multiply the top and bottom of this one by 5, which will give me 2/5 minus 5/5, which is going to be negative 3/5. All right, so my exponent here is negative 3/5. Keep going. Plus 2. Bring down the 1/4 power, x to the 1/4 minus 1, again we're doing some side work, is going to be 1/4 minus 4/4, which is going to give me negative 3/4. There, negative 3/4. All right, and we're almost done. We do not want negative exponents in our answer, and we want to simplify our fractions here. So negative 4 times 2/5 is the same as negative 4 over 1 times 2/5, which is negative 8/5. And this x to the negative 3/5 is going to come to the bottom and become x to the positive 3/5, plus 2 times 1/4 is 2/4, which is the same as 1/2. This x to the negative 3/4 is going to come to the bottom and become x to the positive 3/4. Alright, so that's what that one looks like. And you could rewrite that as a radical. It's good practice, but for this case, just it's fine like that. Number 4 is going to require a little bit of chain rule. Basically what we're going to do is pretend that it was just x to the third and take the derivative of that. All right, so the derivative is going to be, well, 3, whatever that was, squared. But then I have to multiply by the derivative of this inside piece here, right? So what was that inside piece? Oh, let's reveal it. What was it? Oh, it was x to the 5th minus 2. So x to the 5th minus 2. Out here, I need this needs to be the derivative of the inside. That's what I'm writing in there, right? So here's the inside. What's the derivative of that? Well, power rule, 5x to the 4th. Derivative of negative 2 is 0, so I could write plus 0, but that's not needed. And then let's go ahead and simplify. 3 times 5x to the 4th is going to be 15x to the 4th times x to the 5th minus 2. And that is as far as you need to go. Oops, I did forget a little squared on here, didn't I? This squared did not go away. It's still there. So that is the answer. You technically could, multiply that out, but that's simple enough the way it's given. All right, the last one here is find the equation of the tangent line to the function at a given point. Your answers should be in slope-intercept form. Sketch the tangent line on the graph. All right, so we're trying to find the equation of the tangent line, which is this. Right, and actually, you know what? There's another way to write this too. Maybe it's a little bit better. Let's call this x1 and let's call this x1, right? It's that way you know the x coordinate, and actually they give this to us. This is x1, this is y1. Another way to say this is f of x1, right? If I plug in x1, I get 13/2. So we already are given a lot of information. So let's start writing our equation. Y minus f of x1 was that 13 over 2, right? I got that from here. Equals m is the thing that I'm missing, so I need to find that, and then x1 was 2, and the m is simply going to be f prime of x1, which is f prime of 2, right? The derivative evaluated at 2, so there's my function. The derivative of my function is going to be 2x over 2 plus the derivative of x is 1 plus the derivative, plus the derivative of 5/2 is 0. So I could write plus 0 if I want, but I don't need to. And so I need to evaluate this y prime at 2, right? I'm plugging in 2 to this function, which is going to be 2 times 2 divided by 2 plus 1. And you know what? I should have just simplified up here and canceled those 2's, but they just still cancel here. So I have 2 plus 1, which is 3. Right? So that tells me that the derivative when x is 2 is 3. The slope is 3. So I come up here and I put that 3 right there. Right? This is the equation of my tangent line. However, it wants it in slope-intercept form. So I need to do a little bit more work, right? Let's distribute the 3 to give us 3x minus 6. And then we're going to add this 13/2 to each side. 6 is 12/2 plus 13/2. Well, 13/2. Right, we're adding 13/2 to both sides, which is going to give us 3x. Negative 12/2 plus 13/2 is a single half left over. All right, so that is our equation. That is our answer to part A. It also wants us to sketch the tangent line on the graph. So this tangent line is occurring at 2 13/2, so 2 right there. And what we have to remember about a tangent line is that it just comes in, barely touches our graph, and then moves on. So something like that. And it's actually, I made it a little bit too fat, so let's try that again. Let's plot the point 2 13/2, which is there. and then it just needs to come in, touch it, and move on. It'd be easier if I had a line tool on this, but I don't. Anyway, looks something like that, which is this equation here. All right, so that's it for this one. Good luck. I hope you do well on it.